Imagine opening your laptop tomorrow morning and the AI on your screen remembers everything. Not just the last chat, but every project, every draft, every weird idea you typed at 3 a.m. months ago. It picks up your conversation mid-sentence, reminds you where you left off, and connects dots across thousands of pages like it has lived your work with you. That is the world Google just took a step toward with a new architecture called Titans, and it could be the moment AI stops acting like a goldfish and starts acting like a real collaborator. For years, the dirty secret of large language models has been simple. They forget almost everything. Your chat history gets chopped, long documents are sliced into pieces, and once you hit send, most of that context vanishes. Titans is Google's answer to that memory wall, and it is not just a bigger context window spec bump. It is a complete rethinking of how an AI model stores, updates, and protects long-term memory while it is running. And in a minute, you will see why that changes who wins the next AI race. Let us start with the problem Titans is built to crush. Traditional transformers can juggle maybe tens or hundreds of thousands of tokens before they hit a hard ceiling. After that, conversations truncate, documents get clipped, and your so-called assistant forgets what you said 10 minutes ago. The industry tried to patch this with retrieval tricks and vector databases, but those are band-aids, not brains. Here is the pattern break. Titans treats memory as a first-class organ inside the model, not an external plugin you bolt on later. Current chatbots fake long-term memory by searching past logs, pulling a few snippets, and stuffing them back into the prompt. That is fine for simple customer support scripts, but it falls apart when you want an AI to track evolving research over weeks, or remember your personal preferences without constant handholding. Titans pushes beyond that by keeping more than 2 million tokens of active context live. Think multiple full books, plus your email inbox, plus research notes, all in one continuous mental workspace. And the wild part is, it is not just reading that context, it is writing back to its own memory as it thinks. Under the hood, Titans hides a small multi-layer perceptron, a compact neural network, as its memory core. Instead of a static key value cache, this inner network is a live trainable module that updates during inference, not just during training runs. Every new sentence, every correction, every unexpected twist can nudge its internal weights. In plain language, the model does not just look things up, it rewires itself in real time based on what you tell it. That is the key insight. Memory stops being a passive filing cabinet and becomes an active, constantly tuned function. But how does Titans decide what actually deserves to be remembered? This is where Google borrows from human cognition with something they call a surprise metric. Each new token gets scored on how much it deviates from what the model expected. Routine boilerplate barely registers, while rare events, contradictions, or novel entities spike the surprise score and trigger a memory update. In other words, the model is constantly asking, did this change my understanding of the world or this user? And if not, it lets that moment fade. Traditional transformers run brute force attention over every token, every time, which means compute cost explodes as context grows. Titans dodges that by only spending heavy compute on the surprising, high-value tokens that actually shift its internal story. Google hints at orders of magnitude efficiency gains when keeping those 2 million plus tokens in play. So you get GPT-4 level or better performance on long context tasks with fewer parameters and less hardware. This is not just faster, it is a direct challenge to the idea that only giant models win. Think of Titans as a brain within a brain. The outer model handles language, reasoning, and planning, while the inner memory MLP quietly studies everything it stores, looking for patterns across thousands or millions of tokens. Over time, that inner network becomes a specialist in you, your projects, your code base, your data set. Static vector databases, what most chatbots use today, cannot do this. They just dump vectors into a store and pull back nearest neighbors. They never actually learn from the history they are holding. Because Titan's memory is a neural network, it can compress related facts into shared representations. It learns that a meeting note, a bug report, and a code snippet all describe the same issue and strengthens that connection over time. To keep from overflowing, it borrows tricks from optimization theory. Momentum smooths updates so one surprising event has impact while repetitive noise barely moves the needle. And adaptive forgetting lets stale patterns decay as new projects and topics take over. This is a self-curating memory, not a bloated archive. Behind Titans there is an even bigger idea called MIRAS, a unifying theory for modern neural networks. For years, transformers, recurrent networks, and retrieval systems lived in separate research silos. MIRAS acts like a Rosetta Stone, showing that attention weights, hidden states, and external memory are all variations of the same underlying operations on sequences. Once you express them in this common language, you can swap parts, mix styles, and design hybrids on purpose instead of by trial and error. And that opens a huge new design space for future AI systems. Titans is the first proof of concept built directly from MIRAS. Its memory core behaves like a fast, continuous recurrent state while still supporting transformer-style global reasoning over those massive 2 million token contexts. Under MIRAS, that is not a hack. It is a clean, mathematically grounded hybrid. Researchers can now systematically explore models that use recurrence for speed, attention for precision, and specialized memory units for long-term structure. In a sense, MIRAS is less a product and more a blueprint for whatever comes after transformers. So, how does Titans actually stack up against today's giants like GPT-4? Google ran it through Babylon, a brutal benchmark that feeds models documents stretching into the millions of tokens. These tests bury key facts and causal chains deep in oceans of distractors, then ask questions that depend on details introduced hundreds of thousands of tokens ago. Most long context models degrade hard under that pressure. Titans did not just survive. It beat every baseline, including larger, heavily optimized transformers tuned specifically for retrieval. Here is the twist that should make every lab and startup pay attention. Titans reaches those scores with significantly fewer parameters and far lower compute costs than frontier models. No quadratic attention over the whole sequence, less memory bandwidth, fewer floating point operations. That means you can get better long-range reasoning without stacking more and more GPUs. For anyone trying to build serious products or run models on cheaper hardware, this is not just interesting. It is a potential economic shockwave. And Titans is not just a fancy word generator. The same memory architecture is already showing state-of-the-art results in genomics and other sequence-heavy domains, where models must track dependencies across tens of thousands or millions of base pairs or time steps. Anywhere the story stretches long, from DNA to financial time series, a model that can reason over a lifetime of tokens changes what is possible. This is where the road to AGI gets real. Intelligence needs durable, structured memory, not just clever autocomplete. So what does this mean for you, not just for benchmarks? Imagine an AI that remembers every version of your codebase and why you made each change and can explain that history to a new teammate. Or a research assistant that tracks months of experiments, failed ideas included, and suggests new directions based on the entire narrative, not just your latest note. Or a personal tutor that actually remembers how you learn, where you struggle, and how your goals have evolved over years. With Titans like memory, those are no longer science fiction mock-ups. They are product roadmaps. Of course, there is a darker side. An AI that remembers everything about you is also a sensor network that never forgets. Who owns that memory? Who can reset it? Who gets to audit what the model thinks it knows about you? We do not yet have social rules or regulations for systems that build multi-year narratives about individuals and organizations. The race for Titan-style architectures is also a race to define the privacy, safety, and governance frameworks that will keep them from becoming permanent surveillance engines. The AI memory wall was long treated like a hardware limit, something we had to accept. Titans and MIRAS suggest it was more of a design choice all along. By treating memory as a core part of the architecture, not an afterthought, Google has shown a path to models that reason over a lifetime of tokens instead of a single chat window. The next generation of AI will not just be bigger, it will be more persistent, more contextual, and a lot harder to forget. The question now is who will adapt fastest to that new reality. If you want to stay ahead of that curve, now is the time to pay attention. Titans is not just another model release. It is a signal that the race has shifted from raw size to smart memory. In upcoming videos, we will dive into how you could design products, workflows, and even careers around systems that actually remember. So hit subscribe, drop a comment with how you would use an AI that never forgets, and tell me if you want a deep technical breakdown of MIRAS or a hands-on